This is Rodney Cunningham, also known as the Noob, and this is me redoing the intro video I've already done, but I didn't like the way it came out the first time. So I'm going to go over again. To get RC Basic, you go to rcbasic.com and you get to this page right here, which depending on when you visit may have more stuff on it than what it has right now, but as of right now these are just the different sections of the website. Go on there, and what you want to do right now is go to download, and this, as of this video, we are on RC Basic version 2.0.2, and there's currently only a Windows version released. And with this file right here, let me zoom this in, make it a little bit bigger. You have your Windows download, and then this right here is the Android project file, which you would need to build an Android app out of your RC Basic program. Right now, Windows and Android are the only platforms that you can run your RC Basic program on, but in the future, and hopefully when I can get some more developers to join in on this, I'll be able to port it to more platforms. But as of right now, it's just me working on this, so I'm doing what I can to get it on these other platforms, and I definitely am working on it. I really want to get it especially on Linux sometime soon, and provided I can actually get a Mac OS X machine and an iOS device to test the code on, get it to run on those platforms in the future. But for right now, you want to click on RC Basic, download, and just save the folder somewhere. And once you have it downloaded, you'll get a zip file that'll have it'll be a zip file, RC Basic underscore whatever version number it happens to be on at the time. As of this video, it's 2.0.2. So right click and do whatever you gotta do to extract it, and then once it's extracted, you will get a folder that should have all of this in it. Right now, you should have an editor, which is your code editor, where you will be able to just start up the editor and start typing in code right away. RB_RT, which I may change the name of that in a future release, but that is the runtime that runs your compiled code, and RBC, which is the compiler. It compiles your code it compiles your basic code into intermediate bytecode that is run by the virtual machine. As of right now, this other stuff, this application right here is not really necessary unless you have the Android project file, but I went on ahead and included this with the Android project file. This builds your this builds an Android app from your RC Basic program, and this program itself is actually the program that builds your Android program is actually written in RC Basic, and this is the you should have a file called rc_build_android.bas. That's the source code for this, and this is basically I'll go over, and either at the end of this video or in another video, how to attach your compiled code to runtime so that you don't have to continue having to pass it as command line argument to the virtual machine or running it from inside the editor. But for right now, all we want to do is go into the editor, and maximize this, and we're going to just create a new file, And to be able to compile and run the file, we have to have the file saved first. If we try to compile or run the file before saving it, RC Basic will ask us to save the file first. So we're just going to go ahead and save it now. Hit the Save As button, and I'm going to create a new folder on my desktop called Basic Projects. And I'm going to save this as intro.bas. Okay, and now we have our file saved. Before we get into anything, RC Basic is a variant of the basic programming language, and it has like the core features of common basic dialects, but this version of basic is more geared toward, like, I'd say it's probably more geared toward like 2D, like graphics intensive applications. In the future, it will hopefully have a fully functional 3D API built in. That is something like down a pipeline, but it's not going to be in any like immediate release as of this video. So to just get a feel for RC Basic, we're going to, before I get into explaining different functionality features, we're just going to create a simple program just to get RC Basic working. So we're going to type in print, and I'm going to make this bigger so it'll be able to be seen better on this video, but print hello world. And this is a very common program in a lot of languages. It's the first program that most people learn how to write. Is just going to simply write hello world on the screen. And before we run it, we are going to just put this in system pause, and I'm going to go ahead and say right now, this only reason I'm using this specifically is because I'm running this on Windows right now for this video. This is a Windows specific command. System itself is a function that's going to be included with every version of RC Basic, and it's going to just allow you to access the command line functions for that operating system. This is a DOS command that will tell the text window to stay open until a key is pressed. And this right now is we just have this in our program for testing purposes. But if for some reason you are running this on a different operating system, know that system pause will not work. What I would suggest is, if you're on another operating system, at least for these tutorials, have something like maybe just input, and that'll tell you that'll just wait for something to get typed in, and user to press enter, and then the program should just end after that. So now that we have our test code up, let's hit the run button, and we get hello world. I don't know how easily that's able to be seen, but I can't really zoom that in. But that's our first program, and that just gives us a feel for the language. Now that we have our first program up, I'm going to just be going over some basic, the basics of basic, I should say. This is a list of things I'm going to be going over in this video. I'm going to change this order up a little bit and go over comments first, and that's probably because I may end up using comments to show some of the other functionality. But comments is just a basic, it's just simply a way of leaving notes to yourself in your code of what you're doing at certain points. And you don't have to use comments, but especially if you're trying to share your code with other people, it's helpful to have them. And to start a comment, you would just start a line with a single quote, and then from there you can just type in whatever you want, like this is a comment. And when the compiler sees, compiler sees this as the first character on the line, it will ignore the entire line and just go right to the next line. So it's a way for you to just leave notes to yourself and not have to worry about it breaking your code or anything. So now that we got that out of the way, the next thing I think I wanted to go over is data types and operators. And I may go ahead and just transition into variables along with that. So data types, let's go on and start with numbers. Numbers in RC Basic are simply just numbers like the way you would think of them. Like you can have like 5, 4, 44, and then you can also have numbers with decimals, 5 point, and this also, with those numbers and going into operators, you can do math with those numbers. So you can do like 5 plus 3, like 5 plus 4 divided by 3. Before I get too far into that, I'm gonna go over like pretty much the operators that are probably most important to know getting started. The first one obviously is the plus sign. So let's do something like 5 plus 3 and run that, and we get 8. Pretty simple. Let's do a subtraction. So 5 minus 3, we get 2. And now going to multiplication and division. Multiplication is with the asterisk or the star, as some people might know it. So that basically allows you to do multiplication. So this is saying 5 times 3, and we run that, and we should get 15. Division is with this. I guess this would be like a forward slash. I get those two confused, but it's gonna be this slash right here, and that would I'll go with something that could easily be like, so let's go 6 divided by 3, and we should get 2, and we get 2. RC Basics numbers are actually by default. I'm going to throw a big word out there, and I don't expect you to understand it if you've never programmed before, but all of RC Basics numbers are double precision floating point numbers. And what that means is they can have accuracy up to really long decimals. So if we did 5 divided by 3, that's not going to divide evenly, so it's going to give us a decimal number. And it gives us 1.666667. And that what that means by having your precision that high is that you really don't have to, if you are trying to get the most accuracy out of a number as possible, just do your standard addition or subtraction, whatever. If you want to force the numbers to be like whole numbers no matter what, and this is something I'm going to go over later, but I'll introduce it now. You can use a function like int, and that will force your it forces whatever mathematical expression you put inside the parentheses to be an integer. So that 5 divided by 3, instead of that 1.666 whatever, it's going to give us 1. So that's multiplication division. The next thing is an exponent, and to exponent based on raising a number to a power. Like let's say we wanted to do 5 to the second power, we would use this little like I don't even know what this symbol is called, but on an American keyboard it would be Shift 6. I don't know what it would be on a European keyboard or anything, but eventually I will have Unicode support, so definitely want to get support on European keyboards and Japanese keyboards, whatever. So 5 to the second power, and we run that, and we should get 25. And we get 25, and that's exponents. There's two more mathematical type operations I want to go over. The next one is the modulus operator. So let's do something like 5 mod 2. What mod does is it divides this by this, and it returns, or it'll give you the remainder. So 5 mod 2 is equal to the remainder of 5 divided by 2. And we run that, and we should just get 1. We get 1. Now I'm going to go over a few, like there are comparison operators, like greater than, less equal, whatever. Before I go into those, I'm going to go into these two things. Print true. Let's print true first. True is a built-in expression which is going to basically always be equal to 1, and that's true is basically and you'll see later on in logic, control flow, and stuff like that. True is an expression that comparisons look for in order to determine whether it's going to do certain things in a program. But and false is going to be always equal to 0. We get 0. So if you think of true as 1 and false as 0, when you do an expression like 6 is greater than 1, 6 is greater than 1, so this expression is equal to true. So if we run this, true, it's not going to print true, it's going to print the number that true is equal to, which is 1. So we run that, and we should get 1. And we get 1. And if we did 6 is less than 1, we get 0 or false. And we could do 6 equals 1, and we get 0 or false. And those are like some of the comparisons. Like the different comparisons you have is like you can do something like greater than, so like you do 5 greater than 3, or 5 less than 3, and greater equal, or less equal. And then something that may be confusing, especially to somebody coming from another language, but not equal. And this basically is saying if 5, like return what 5 not equal to 4 like evaluates to, and 5 is not equal to 4, so this expression is true, so it should write 1, and we get 1. And that's it for those operators. I think the next thing I'm going over is and, or, XOR, and not. So and is this expression is going to return 1, which I will show you, then I'll explain why. It returns 1. And the reason that is because this expression is comparing, it's basically saying true and true. And true is for all intents and purposes, it doesn't necessarily have to be 1, but well, it's 1, but the reason it's 1 is because think of this like don't think of this as a number, but as an expression. And this expression doesn't do any kind of comparison. Like this expression, like a normal expression you would think of is like maybe 5 plus 4 or 5 greater than 2 or whatever. But this expression is just a single number. And that number itself, it's just a number, so it's true. And true is basically saying it's not 0. So if we did 0 and 4, we get 0. So anything that's not 0, like before and after this and, is going to cause this whole expression to be true. Like a 0, like so this, when you have and, basically this has to not be 0 and this has to not be 0. Both sides of and cannot be 0, otherwise the whole expression is going to be false. And when you think of 0, 0 is false. So like, you could do something like 3 greater than 4 and 4 equals 4. Now on this side of the expression, 4 is equal to 4, so this is true. But 3 is not greater than 4, and that's false. So false and true is false for this whole expression, because and says that if this is true and this is true, the entire expression is true. So this will return false or 0, and we get 0. And if we set that to like 2, the entire expression is now true, so it's going to print 1 and writes 1. Or is like and it's looking at both sides of this, but or only needs one of these conditions to be true. So or is saying, like, if this side of the expression is true or this side of the expression is true, the whole expression is true. Only one side has to be true. So we could set 3 less than 2, which is false, but 4 still equals 4, so this whole expression still will return 1. And we get 1. And we could do 3 greater than 2. Now both sides of the expression is true, and as long as at least one side of the expression is true, it's always going to return true, so it returns true again. The reason I brought that up though is because of XOR, which is stands for exclusive OR, and its special condition is that only one side of the expression has to be true and one side of the expression has to be false, otherwise the whole expression is false. So right now 3 is greater than 2 and 4 equals 4, so both sides of the expression is true, so this expression is false, because with the XOR, one side has to be true and one side has to be false, so this will return 0, and we get 0. Now if we made one side of the expression false, like make 3 equals 2 XOR 4 equals 4, and now we get true. And last thing is not, which not is basically it's going to return the reverse of what the expression evaluates to. So if the expression evaluates to false, nodding the expression is going to return true. If the expression evaluates to true, nodding the expression is going to return false. So let's just write not true, and that's going to return 0. And if we did not false, 1. And then would add an expression there like 5 greater than 2, and run that. And we get 0 because 5 is greater than 2, so nodding it is going to make it false. And that's pretty much it for, like, expressions and how to use them in, like, mathematical expressions and equations stuff. Now I'm going to go into strings. At the beginning of this video, we did a print hello world. This is a string right here. This whole expression. A string, like string literals, are between double quotation marks. So anything between these quotation marks is just treated like it's treated as a string of characters, which is why it's called a string. And a character is basically anything that can be represented in text on a screen. And not even necessarily in text. There's characters that don't have like a text value for them, but for string purposes, it's probably going to be it's going to be text or something like it. Anyway, I guess. So this is a string of characters that starts with this H and ends with a D. The double quotation marks are not part of the string. They just contain the string. Kind of like this in this system pause. This pause is in double quotation marks. So the pause is the string that gets passed to system, not the double quotation marks. The double quotation marks are just there to separate the string from the rest of your program. And to be able to add to string, like you can add, like, obviously, since anything inside this quotation marks is just a string of characters, you can type in whatever you want, and that's just treated as a string, and it'll write that to the screen with print. So to add to a string, though, like let's say we wanted to add two strings together, we could have hello, and then we could do plus, just like we would with adding two numbers, and world, and it will combine these two strings, and we get hello world. And no, it doesn't have a space between them, because the string itself is going to only contain what you put in between those quotation marks, and we didn't put a space in between these quotation marks here or before the W or anything. We just had hello as one string and world as one. So when it combines them, it doesn't put a space in there. It puts only what you tell it to go in there. And you could do plus and put a space here if you wanted, or you could put a space after this O right here, or you could put a space before the W, and it would have put a space between the two words. And a special little character that can be used also to add strings together is the ampersand. And this only works on strings. It will do the same thing that the plus sign does to strings, and it will just add those strings together. And that's it for data types. Those are the only, RC Basic only has those two data types. And unlike other programming languages which may have different data types for numbers, RC Basic only has a number data type that can hold any type of number in it. Strings are just that. They're like a string data type. It can be used to hold a string or just one character or whatever you want to put in there, as long as you're treating it as a string. Now we can go into variables. There are two different types of variables. You have number variables and string variables. Your number variables you could make just by doing x equals 5. Now you've made a variable called x and you've set it equal to 5. So we'll print x and we'll write 5 to the screen, because when you call print or a function and you pass this to it, it's not passing the letter x, is passing the value you stored in that variable. And since x is the value that's stored in a variable, you can do math on x just like you would on the number 5. So you can do x plus 3. and you get 8. Another thing that I forgot when I was going over like order of operations, and before I go into string variables, I guess I'll go over this real fast. The order of operations, yeah. So we had before, we did the plus, minus, multiply, divide, and all other stuff. But another thing I should note is RC Basic adheres to the order of operations, in that you have a certain order that mathematical expressions are executed in. So let's say we did something like 4 plus 2 times 3. Oh, 2 times 3, yeah. In this expression, if you were just going from left to right, you would probably be saying 4 plus 2 is 6 times 3 is 18. But that's not the order this is getting executed in. And the order of operations is parentheses, exponents, multiplication, division, addition, and subtraction. So in that is looking for a parentheses group first, which we don't have in this expression. Then it looks for an exponent, which we don't have in this expression, so it goes to multiplication and division. And it has multiplication there, so it's going to do this multiplication first, which is 2 times 3 is 6. So it does that, multiplication first, and it will replace that 2 times 3 with 6. And then it will do 4 plus 6, which is 10. We run that, we get 10. And this video really isn't going to go too much specific into order of operation. You can look up any math tutorial on that if you're confused on that, but it's something that they teach in school, so you should, if you haven't taken 5th or 6th grade math, you can find tons of tutorials on just order of operations on the internet. The next thing I will go into is string variable. So we made a variable called x, which is equal to 5. Now we can make a string variable. We'll call this b. And I'm naming these variables just letters, but you can actually name the variables with whole words if you want to. So I'll call this variable word, and or actually no, let's name it something ridiculous like tree. And here's what and now we've made a variable called tree, but it's not a string variable yet. To make a variable a string variable, when you first create that variable, you have to put a $sign at the end of it, and then you set it equal to like a string. So actually I'll just put yo in it. So now we have a string variable called tree, which remember, to have the string variable, when you first create it, it has to have that $sign in it. And I say when you first create it because now that we've created that variable, we can just do print tree, and it prints yo, and we don't have to have the $sign in it anywhere else in the program we use it. But we can have the $sign in there if we want, and it will still work. And we get tree. And this next part is basically how to make another way to define variables. And so if you wanted to make a variable and you didn't want to set it to a value right away, you could just do something like dim x or dim tree, and we made a number variable called x and a string variable called tree. But with using dim, we don't have to set a value to it or anything right away. We could just create the variable and then worry about setting it later. That actually leads into our next part, which is on arrays. So an array is a way to store multiple values in a single variable. And to create an array, you would just open up a square bracket, set how many elements you want in the array. We'll do 5 and 5. And now we have an array of 5 numbers and an array of 5 strings. And so let's say we wanted to set x. We could do x0 equals 4, x1 equals 6, x2 equals 44, x3 3 equals 9, and x4 equals 2.04 04. And we've set all the elements in the array. Somebody might have noticed that the last element in our array was 4, although we set it to 5 elements, but you notice our first element is 0. So 0 to 4, if you look at this is 5 different elements in the array we've set. And now these variables, like like an array, can be used just like normal variables. So x0 is like its own variable, x1 is like its own variable, x2, and so on and so forth. And we can do math with those variables. Like, let's say we did x1 plus x2, and this is taking x1, which is 6, plus x2, which is 44, and that should output 50. We get 50. String arrays are the exact same, so we could do tree, and you can, like I said, add the $ or not, and then you could pick 0, tree 0 is hello, tree 1 equals world. And I'm not going to set all tree, so I'm just going to say print tree 0 plus a space plus tree 1, and that will print hello space world, and hello space and world. And that's it for arrays. The next thing going over is IO. The IO is short for input and output. We went over a one way to output text to screen with just print. So like when we say print something, print writes that to the screen. That's output to the screen. Another way to do like text output to a console screen is like just using Fprint. And Fprint is not a keyword, but it's a function. So like functions like the system function right here, which has open and closing parentheses. Every function has to have that open and closing parentheses, along with whatever arguments you're passing to it, which I will go over a little bit more in depth when I get to functions and subroutines. So we could do print, this is a string, and fprint, the difference between fprint and print is fprint does not have an automatic line feed. So for instance, let's just do fprint this second line, yes, and it's going to write this on the first line, this on the first line, and then that text you get from pause where it asks you to press a button, continue, that's all going to be on one line, because fprint does not automatically go to the next line. And we just get this one massive ugly line. Now you can, like with fprint, because it doesn't go to a line, you can still make it go to the next line by using what's called an escape character for next line, which if we go to reference, and I don't think I've explained that yet, so if you go into your help menu you have about and reference. Reference just brings up the documentation where you can look up something if you don't remember what you need to type in. And like when you get into the documentation, you have all these different areas you can go into. Right now we just want to go into escape characters, and it brings up a table of escape characters that we can use. This /n is the character we want. It inserts a new line into a string. All of these are just ways of inserting like certain types of characters and strings that wouldn't otherwise be possible. Like in order to insert like this slash into a string, you have to put a double slash in the string for it, because the slash is used as an escape character for all your other escape characters. So to actually make it go to the next line, we just put /n at the end of that and /n at the end of that. And now we run that, and it skips to the next line each time. Let's go over some input real quick. So input, there's one function for accepting input from the screen, and that is the input function. So like input function takes one string argument, just like system, and that argument is just what the prompt appears on the screen before reading your input. So let's just put enter something for our prompt and run that. Now it has entered something, and it's just waiting for us to type some text in, and we hit enter and nothing happens. To be able to do something with the text we get from input, we gotta store it in like a variable. So to store that in a variable, input is a function that returns a string. You notice when I wrote this, I put a $sign at the end of it. I didn't have to have the $sign in it, but I like to keep $signs in there to differentiate between string and number functions. And input is a string function, so it's going to be equal to the string of text that you type in. And to store that in a variable, we just create a string variable. Let's make it a equals input. Now we could go down to the next line and print you typed in plus a, and we run that and put noob, and it says you typed in noob. And that's a simple way of getting input from the screen and doing something with it. And now we went over input output. Let's go into flow control. This is going to be a little bit more involved than what this video has been up to this point. So flow control is if statements, and like you have two different flow control constructs. You have an if block, and then you have a select case block. The first one to go over is if. So like let's say let's make a variable called x equal to 5 again. Now let's do if x equals 4, then print x is 4, or something like that. And then you could do else, print x is not 4, and if, and run that. When we run that, first thing it's doing is setting x equal to 5. So when this line, which you probably understand even if you haven't programmed anything before, if x equals 4, which is not, then it will do this, which it won't do this because x is not equal to 4. And so it goes to else, and else is basically if this condition is not true, it's just going to do this, and it's going to say x is not 4. And we get x is not 4. So we can actually extend the if statement even further, and we can extend the if statement as long as we want by using something like else if. And else if has two ways of writing it. You can do it as one word like I did here, or you can separate it into two words, and it's going to do the same thing regardless. But I like to typically keep it as one word. So if we did else if x equals 5, then print x is 5. So now it's going to do the same thing. It's going to check to see if x is equal to 4, which it's not. So it won't do that. And then it's going to say else if x equals 5, then do this. And we could extend this as long as we want. I say we could add else ifs in there saying x equals whatever x is less than 2 or something like that. Make sure we're ending our ifs and our else ifs with then. We don't have to have then at the end of else. So we run that, and it should just say x is 5 because it's checking here to see if x is equal to 5. Then it's going to do what's between this, and then it's going to just jump to the end of the if statement. And it says x is 5. So now let's go over select case. So select case x, and we'll say case 1 print this, case 2 print that, and we're just going to skip to case 5, print hello world, and select. Oops. And select. And I'm going to add some tabs in here to make this just a little bit more readable. I guess I'll tab that too. So, and that. And there. I'm hoping that made it look a little bit more readable. Select case is very similar to if, and it's in this situation it's pretty much doing the exact same thing. The first thing is checking, like select case has its select case, which is x, and basically x is getting compared to each of these cases 1, 2, and 5, and if x is equal to one of these, it's going to execute the code in that case, which it's going to go to case 5 and just print hello world. And the reason print hello world is because x is 5, so 5 is obviously equal to 5, and it's just doing that. But if we had, like, I'm going to change this to 3, and now none of these will run because x is not equal to any of the cases, and we get nothing. But we can add something called default. And default is basically if x is not equal to any of these conditions, the default condition will just automatically run if we set it. So we could print default and run that, and we just print default. And that's it for flow control. Next thing I'm going over is loops. There are 3 different types of loops that you can use in RC Basic. The first type I'm going to go over is a for loop. So a for loop is basically if you know the number of times you want to loop through something, you could set your for loop for that, and it will loop through that many times. And basically a loop is a way of repeating a section of code, like a certain amount of time. So let's say for instance we wanted to print the numbers 1 through 10. We could do something like print 1, like print 1, print 2, print 3, print 4, print 5. And you see how this is kind of getting monotonous already. We could do that. We'd end up wasting 10 lines to print the numbers 1 through 10, or we could do it in 3 lines with a for loop. So to do that, we would start our for loop with just the word for, and then we would have a variable we'd create. It has to be a number variable too. So we're gonna make a variable called I, and we'll set it equal to 1 to 10. And what this is doing is basically I is going to be equal to 1, and let me type this out and I'll explain it a little bit better. So I starts out equal to 1, and after it sets I equal to 1, it's going to jump into the loop and it's going to do this code print I, and then we get to this line next. Next jumps back to I, and it increases I by 1, so now I is equal to 2. So it's going to print I, which this time is 2. Then it goes to next, which is going to jump back up to I and set I equal to 3, and it's going to keep on increasing I by 1 until I is equal to 10. And then it'll print I, get to next, and then it'll exit. So it'll write the number 1 through 10. And we get the numbers 1 through 10. And the last thing on the for loop is we could use step. And step is basically, like I said before, I was increasing by 1 each time automatically. Step is basically saying instead of increasing I by 1, I want to increase it by 2 every time. So this time I will be equal to 1, it'll print I, get to next, jump back to I, and it's going to increase I by 2 this time, so it's going to go to 3, so I will be equal to 1, 3, 5, 7, and 9. And then like increasing from 9 will go to 11, which is greater than 10, so the loop ends. So this will basically write the numbers 1, 3, 5, 7, and 9 to the screen. And we get 1, 3, 5, 7, and 9. And that's it for loops. The next loop I'm going to go over is the while loop. And a while loop is basically a way of repeating like a block of code while a condition is true. So we have while, and then we have our while condition, which let's say while, well, we'll create a variable first. So let's create a variable just here called I equals 0, and then we'll go while I is less than, or while I is let's do like we'll make it do the same thing the for loop did last time, just so you can have something to reference. So while I is less than or equal to 10, and then we're just going to print I and when. And here's what's going on here. So we set I equal to 1 right here. We created a variable I here and made it equal to 1, just like we did with our number variables earlier in this video. And now we're saying while the variable I is less than or equal to 10, we'll print I. And one thing we didn't do though is we didn't the while loop doesn't automatically increase this variable. The while loop is just checking to see if this condition is true. So if we ran this code like it is right now, it's just going to print the number 1 infinitely. And we get the number 1 just going on forever. So to make this actually write the numbers 1 through 10, we have to increase I ourselves. So we would do that by saying I equals whatever I currently is plus 1. And the reason we didn't do I plus 1 is because I plus 1 is just an expression that's adding I and 1 and then not doing anything with the value that's returned. So we want to set I equal to I whatever I is currently, which is 1, and starting out it's going to be 1, so we're making I equal to 1 plus 1, and then when it gets to 1, it jumps back up to here, and like I is at 2 at that point, which is still less than or equal to 10, so it'll write I to the screen, and then we'll set I equal to 2 plus 1 then, and then go back through here, and then I will be equal to 3 plus 1, and so on and so forth. So now we should write the numbers 1 through 10 to the screen. And we get the numbers 1 through 10. The last loop I'm going to go over is do. And do has a few different forms. The first one is just loop. And this is basically an infinite loop. So we could just say print I. And it's just going to loop infinitely, printing 1 to the screen. Right, and it may be useful in certain cases to have an infinite loop, but sometimes you want the loop to end. So we could do loop while, and this while just checks while something is true, just like in the while loop. So we could say while I is less than or equal to 10, and let's increase I by 1 just like we did in the while loop. Have this, and now we run this, and we get the numbers 1 through 10. And it's like in that situation, the do loop while may seem similar to the while loop, but the difference is the while loop. You notice when the while loop, we type while in the condition at the beginning of the loop, and in the do loop we typed it at the end of the loop. The while loop checks for that condition at the beginning of the loop before it even runs. The do loop won't even check for that condition until after it's done all this. So the do loop, in any form of the loop is guaranteed to run every bit of code in the loop at least once before it even checks for the condition to see if it's true or not. The while loop, if I started out at 11, the while loop would have never ran. But the do loop would, simply because like the do loop doesn't check for like anything until it gets to the end of the loop right here. So all of this will happen before it even checks to see if that's true. And that's basically one form of the do loop. The other form is until. So we could say like instead of looping while a condition is true, we can loop until a condition has become true. So let's say we wanted to loop until I equals 10. Now this is not going to write the numbers 1 through 10. This is going to write the number 1 through 9, simply because the do loop, we start out setting our variable I equal to 1. So we're going to write 1 to the screen. And then we increase I by 1 here, and we check that. But when we get to the point where we write 9 to the screen, and then we say I equals, if I is 9 at that point, 9 plus 1, I is going to be equal to 10. And then it's going to loop, and it's going to go here and check until I equals 10. And I is equal to 10 at that point, so the loop will just end. And it only wrote the numbers 1 through 9. So we only get the numbers 1 through 9 on the screen. We get 1 through 9. And that's it for loops. Something I will be going over loops more in future videos, but this is just an intro, get your feet wet, you know. And functions and subroutines. So functions and subroutines are, we've actually been using a few of them. This right here is a function. This function basically allows you to send commands to the operating system to execute. Functions there's a whole if you pull up your reference, you have like boatloads of functions for like different categories. Like let's say for math, you want to go to math and you have all these mathematical functions like, you know, ABS, which is returns the absolute value of a number, or like sin, which, you know, returns the sign of a number and stuff like that. So I'm not gonna use all of these functions, but I'm gonna go over a few different ones. So we'll go over ABS first. And ABS, like when you go into documentation and you see ABS and you see, like, you know, like these variables inside the parentheses, that tells you how many arguments that function takes. So this function, I'm going to use a function that takes 1, and then maybe a function that takes, I know min and max take 2 values. So let's use ABS first. It returns the absolute value of a number. So let's print ABS -4. And this is going to return the absolute value of -4, which an absolute value is just a positive of whatever number you put in. So negative and positive 4 have an absolute value of 4. And we get 4. And we can use the, you know, function, since this function is returning a number, we can use it in, like, multiplication. So absolute value of negative, or like any kind of mathematical expression. So you can add, subtract, multiply, divide. So let's just multiply the absolute value of -4 by 3. And this is going to return the absolute value of -4, which is 4. And it's going to say 4 times 3, which is 12. And we get 12. Now another function I'm just going to go over real quick, just to show you how multiple arguments can work in a function, is max. Max returns the highest of 2 numbers. So let's say we'll print max 5 and 3. And it's going to print the highest of the 2 numbers passed to it, which is 5. But this function, unlike a lot of functions we've used up to this point, is taking 2 numbers. So we separate those 2 numbers by a comma. And some functions will take, there's other functions that will take like 4, 5, 6 arguments or whatever, and each argument has to be separated by a comma. Also, like, there's functions that take numbers as arguments and functions that take strings as arguments, and there's functions that take both, like I know file, like the file open, which is not something I'm going over in this tutorial at all, is going to take it takes a number called string, a string called file name, and a number called mode. And you would separate those by commas, but where it's a string, you can either pass a string variable, or you can pass a string literal into quotation marks, just like I showed you earlier. But we are definitely not going over that. So we're just gonna go with this, and it prints the max of these 2 numbers, well, the highest of the 2 numbers passed to it, which is 5, and we get 5. And that's one thing separate. Subroutines are like functions, but they don't really return a value. And by, like, when I say they don't return a value, they're not numbers or strings. However, a subroutine, like, let's find a subroutine in here. I don't even know if there is I'm pretty sure a lot of these are implemented as functions, so I can't think of a subroutine right now. Heck, I know, like, these are drawing commands, so they won't work at all right now. I'll go over in another video how those work, but box is a subroutine that draws a box, and it takes 4 numbers. So I'm just going to put 4 random numbers in it. I've done a video, there's already a video in the video series on graphics programming, so check that video out if you want to know how box and how to draw graphics on the screen and stuff. and then I'm doing a more advanced video in the future on like advanced graphics programming, like scrolling and tile scrolling, like alpha blending and some other cool effects you can do. But this right now will print 0 because all subroutines will return 0. Well, they won't return anything. This actually doesn't return anything, but the print statement will just take a subroutine and make it return 0. But let's say we did it inside the fprint function. Still get 0. So like subroutines are like, they don't really return anything, but inside of a inside of a keyword or function that you pass it to, it's going to force it to return a 0 because it would crash otherwise. And now we will go into that's basically function. And also there's different types of functions. You have, like, we went over number functions so far, so let's go over a string function, which I've already covered. A string function already. The input function, it returns a string, but we'll go over a simpler string function, like let me open this up. Let's go over, we'll use a uCase. That's a good function to use. uCase takes a string in and it returns that string with all the characters capitalized, uppercase. So we'll use uCase and we'll just take a string and put it in there, like hello world, and it's all lowercase right now, but uCase returns that string capitalized. And like saying, since this is a string function, you can use it with with or without the $sign and it will still work. And we run that and we get hello world, all capitals. And now we can go to how to build your own functions and subroutines. So to make your own function, you would use the function keyword, and then you would set a name for your function. So we'll call it my function. My func sounds kind of weird. So my function, and you can choose to have it as like any type of arguments you want in there. You just have to give them names. Like we'll just pass x to it. And so now we could just make our function, like inside of our function we could do something like a equals x plus 4, and then return a and function. So what this function is going to do is we're going to pass a number value to it, which is x. The variable x is going to be set to the number value we pass to it, and then inside the function we create a variable called a, which is equal to the number value we passed, x, plus 4, and then it's going to return a. And return, basically, because you've heard me use that in this video probably a few times already. Return is basically saying my function is going to be equal to this. So it's going to be equal to whatever you pass into it plus 4. And print, we'll use my function, and we'll pass 5 into it. So this is going to pass 5, make x equal to 5. And so we create the variable a here, and a is going to be equal to 5 plus 4, which is 9. And then it's going to return 9. So it should write 9 to the screen. And we get 9. And real quick, I'll also go over that functions can be numbers or strings. To have a string function is just like creating a string variable or a string array. You would just put a $sign at the end of the function name. And now we can no longer return a number, we have to return a string. So let's return hello world. I've used that quite a bit, but it's just the first thing that comes to mind. Now this function, we pass 5 to x, a equals x which is 5, plus 4, which is 9. So a is still going to be equal to 9. But we don't even return a anymore. We don't do anything with a, x, or anything. We're just going to return hello world. So no matter what we type into here, we could type in, like, not that, but we could type in a bunch of random numbers like that, and it's still going to print hello world, because that's what this function is returning. That's what this function is going to be equal to, is hello world, no matter what. And we get hello world. And that's how to create a function. Let's go over how to create a subroutine. So sub, you're going to use the sub keyword this time, and then we can say my sub. And you know, we don't have to accept any arguments. We can accept a number argument, we can accept a string argument just by putting a $sign at the end of the variable, whatever. Or we could choose to accept nothing. So we'll just accept nothing, and then this subroutine, the only thing it's going to do, we'll have it write the numbers 1 through 10 to the screen, just like we did when we learned the for loop. So I equals 1 to 10, and then print I, next, and then end sub. And to use that subroutine, we don't need to store a value from the subroutine, and you know, it's writing to the screen already, so we don't really need to use print. So we'll just say my sub like that, and this is just calling my sub just like we made it right there. And we didn't, you know, make like any variables inside of the parentheses or anything. So my sub, when it's called, is just going to execute this code, and we get the numbers 1 through 10 on the screen. And the last thing I'm going to go over in this video is scope. So let's say I'm going to actually, I'm going to leave that function here, but I'm going to take this out just to demonstrate something. So my sub is going to print a, we're going to make a variable here called a equal 5. So when we call my sub, it's going to print a, which we made here. So a was made before my sub was made. So this variable a, we can access the variable a since we already made a right here. So we run that, and we get 5. But let's do something crazy. Let's say we didn't make a before that. Let's say we made a inside of sub. We made a here. So like a equals, say equals 5 here, and my sub isn't going to print anything out. So we make a variable called a equal to 5 here. So we call my sub, and when my sub is called, it's creating a variable called a and setting it equal to 5. So now let's try to print a and see what happens. And we get an error. I'm not going to read the error, but the error happens because a is not defined. Yes, we created a here, and yes, we called my sub here, which jumps in here and creates this variable a, but it's creating this variable inside the subroutine, so nothing outside the subroutine can access it, because a is like in a scope that you can't access outside of my sub. So another thing too is, like, let's say we created a variable called a here, then so we'll set a, make a variable after we created a subroutine called a equal to 2, and then we call my sub, which, oops, go back, my sub, which sets a equal to 5 after we made it equal to 2. So since we called my sub, you would think that this would write 5 to the screen, but it's going to write 2, simply because that variable a is still outside the scope of the rest of the program. So this will write 2 to the screen. And that's because any variable created inside of the subroutine is only can be accessed within that subroutine. The same thing for loops and all that other stuff. Now you could replace the sub with function, or replace it with a while loop, a for loop, whatever. Anything created inside of a block can't be accessed outside that block. But if we create a before we create, if we create the variable a before we make the subroutine, then we can access a inside the subroutine. So let's say a equals 1. So now when my sub is called, it's setting this variable a equal to 5. So this will write 5 to the screen. And it writes 5 to the screen. And scope is, maybe a little bit difficult to understand at first, but just know, if you don't create a variable before you make a subroutine or a while loop or whatever, that variable cannot be accessed inside that sub. So it's going to create a new variable called a local to my sub, and then set that to 5. And then when the subroutine ends, this variable is just discarded. But not in this case though, because we created a before we made the subroutine. So this subroutine can set this variable a equal to 5. And that's basically it for scope. Definitely, if you found this video useful, appreciate a like. RC Basic is free software under the MIT license, open source, and a link to the source code can be found along with downloading RC Basic at rcbasic.com. And for any help or feature requests, bug tracking, whatever, go to the RC Basic forum, and I will see you.